Good morning, students. I'm Karpagam from SRM Engineering College. I'm handling the paper Transforms and Partial Differential Equations. The subject code MA3321. Partial differential equations. Already you studied in plus 2 level ordinary differential equations. Here discussed with partial differential equations. Already we know that what is ordinary differential equations? Only the one dependent variable and only single independent variable. That equation is called the ordinary differential equations. But here we are going to study partial differential equations means more than one independent variable. That is the basic concepts in partial differential equations. It is the operator is dou by with respect to x variable means dou by dou x. Dou by dou y with respect to y. Similarly, second order dou square z by dou x square. This is the introduction of partial differential equations. So that is the more than one independent variable is called the partial differential equations. Here generally denoted as z equal to f of x comma y. Here z is the dependent variable and x and y is the two independent variables. So here the notations, generally we are using the notations dou z by dou x equivalent to p. Dou z by dou y equal to q, dou square z by dou x square equal to r, dou square z by dou x dou y equal to s, dou square z by dou y square equal to t. Here we are using the notation P, Q, R, S, T. That is partial differentiate with respect to x means P, partial differentiate with respect to y means Q, 2 times with respect to x means R, 2 times with respect to y means T. Only one time with respect to x, another time with respect to y means it is denoted as S. So this is the main notations of PDE. Here we have the formation of PDE. The two types of formations, one is the elimination of arbitrary constants and then the second one is the elimination of arbitrary functions. So what is the elimination of arbitrary constants? Here consider the first equation f of x comma y comma z comma, here the two constants a comma b equal to 0. Here the x, y, z is the, already we know that the variable, x, y is the independent variable, z is the dependent variable and a, b arbitrary constants. The type 1 is the elimination of arbitrary constants. Here we are eliminating the constant terms a comma b. So here we take it as the first equation partially differentiate with respect to x. So we get dou pi by dou x. For example, here the phi is the function means dou pi by dou x plus p with respect to p and then dou pi by dou z. Z is a dependent variable, so we get dou pi by dou z equal to 0. So here take it as the pi function. Similarly, partial differential with respect to y means here the dou pi by dou x or dou f by dou y plus q into dou pi by dou z equal to 0. So here the equations one again after that partial differentiate with respect to x and y we get the second and the third equations. So automatically eliminating the a and b arbitrary constants we get the alternate arrangements P and Q. P and Q some partial differential equations notations. So we get the partial differential equations of the first order of the form f of x comma y comma z comma p comma q equal to 0. So here the eliminating a b instead of we get p comma q equal to 0. This is the second one by elimination of arbitrary functions. Here we take it as two functions u and v. Here the relation is u equal to the function of v. So here take it as first equations. Similarly, the same pattern we continue the arbitrary functions also. Here the differentiate one with respect to x and y. Here eliminating the arbitrary functions we get f of x comma y comma z comma p comma q equal to 0. So this is for example eliminating the arbitrary constants a and b from the here we get z equal to ax plus by plus ab to construct the original PDE. So this is the take it as given equation is the first equation z equal to ax plus by plus ab. Here the first equation differentiate one with respect to x with respect to the independent variable x as well as y. So we get dou z by dou x equal to a. Already we know that the notations dou z by dou x equivalent to P. Therefore, we get P equal to A. So, take it as second equation. Similarly, the first equation differentiate with respect to Y. So, dou Z by dou Y equal to B. Already we know that the notation dou Z by dou Y equal to Q. So, then we get Q equal to B. So, using the second and third equation, substitute the first one. So, automatically eliminating the arbitrary constants. So, Z equal to Px plus Qy plus Pq. This is the original PD of the given problem. Similarly, the second example, construct the partial differential equations by eliminating the arbitrary constants A and B. Here the problem is Z equal to x square plus A square into Y square plus B square. The given problem, take it as first equations. Here we have the two independent variables x, y. Similarly, two arbitrary constants A and B. The same procedure we have to follow the example 1. So here the differentiate 1 with respect to x and y. So partial differentiate with respect to x means dou z by dou x. So notation is p equal to 2x y square plus b square. Again with respect to y means dou z by dou y. So here 2y into x square plus y square. So here our notation we get p equal to 2x into y square plus b square, and then similarly q equal to 2y x square plus a square. So substituting the values of p and q in the first equation, so already we get what is x square plus a square value is q by 2y. Similarly, y square plus b square value is p by 2x. So p by 2x equivalent to a square plus b square, and then q by 2y equivalent to x square plus a square. So substitute the first equation, we automatically eliminating the arbitrary constants, we get 4xyz equal to pq. The next one is the solutions of the partial differential equations. So here we have the singular integral, complete integral. We have the many solutions. Here the general of singular integral. Here we take it as first equations. F of x comma y comma z p comma q equivalent to 0. Here the complete integral is solving the first one. We get the complete solution is f of x comma y comma z a comma b equal to 0. Already we know that here a and b is the arbitrary constants. Here we take it as the second equation with respect to a and b. So automatically eliminating the arbitrary constants, dou pi by or dou f. Whatever it is, the functions pi or f. So dou pi by dou a equivalent to 0. Here take it as third equation, and then dou pi by dou b equivalent to 0. Here that fourth equation. So eliminating of a and b from the equations of 2, 3, 4. So we get the integral of the equation. That is the solution of this equation. This is the general procedure. The last one is the general integral. Here after the complete integral solution, we get here instead of b replaced by the function of a. So automatically the above equations are replaced by f of x comma y comma z comma a comma f of a equivalent to 0. So again, similarly, they differentiate the second equation partial with respect to the arbitrary constants a. So we get dou pi by dou a plus dou pi by dou b f of a equal to 0. So elimination of the fifth and sixth one, we get the general integral of the first equations. So the very important topics, then another one is the Lagrange linear equations. So it's important in PD's paper. So transforms and differential equations paper. So one of the important repeated university questions in this topic. So the first one, we have the two types of the Lagrange linear equations. One is the grouping method, and then another one is the multipliers method. The general form is the Lagrange linear equations, capital P into small p plus capital Q into small q equal to R. Here capital P, capital Q and capital are the functions of x, y, z. This is called the Lagrange linear equations. Suppose solving this equation, we consider the constant term u equal to a or some constant u equal to c1, and then similarly b equal to b or b equal to c2. Some we take it as any one constant c1, c2 or a and b. Here a and b constants, already we know that u is the functions of variables x, y, z. So look at the using the differential equations, du equivalent to dou u by dou x, dx plus dou u by dou y, dy plus dou u by dou z into dz. The general total differential derivatives. So the comparing the second one and then third equations, Here dou u by dou x into dx plus dou u by dou x. By using the partial differential equations, with solving this equation, finally we get the auxiliary equations. Dx by capital P equal to dy by capital Q equal to dz by capital R. Using the total differential equations, we get the subsidiary equations are fifth equation. This is called the simultaneous equations, which are first order and the first degree. The two solutions of fifth one, u equal to a or otherwise v equal to v. This is final solution. F of u comma v equal to 0 is the solutions of the Lagrange linear equations. This is the right one note. So to solve the Lagrange equation, we have the form of subsidiary equation or otherwise the auxiliary equations. It is written as dx by capital P equivalent to dy by capital Q equivalent to dz by capital R. This is the Lagrange equations or otherwise the subsidiary equations of Lagrange's method. So this is the examples of Lagrange linear equations of multiplies method. The example, find the general solutions of mz minus ny into t plus nx minus lz into q equal to ly minus mx. So for step 1, first of all write the auxiliary equations or subsidiary equations. Dx by capital P equivalent to dy by capital Q equivalent to dz by capital R. So already we know that what is capital P. Capital P means mz minus ny, and then capital Q means nx minus lz, and then capital R means ly minus mx. So here using that Lagrange multipliers, most of them we are using the multipliers is x by z or otherwise 1 by x, 1 by y, 1 by z or some constants 1 comma 1 comma 1. So in this problem we have to select the according this problem we select x comma y comma z. So multiple by numerator in x and as well as denominator in x, automatically denominator converted to 0. So the each fraction of the subsidiary equation we get x dx plus y dy plus z dz divided by automatically first fraction multiple by x plus second one y, third one z, automatically the denominator goes to 0. So we get the numerator x dx plus y dy plus z dz equal to 0. So now integrate with respect to these equations. So x dx means x square by 2 plus y square by 2 plus z square by 2 equal to some constant c1 by 2. So eliminating the two equal constants. So here we can rewrite this equation x square plus y square plus z square equal to c1. So this is the first solutions of the general solution of the PDE. So here we have the one solution. We have to find the another solution. So we are using the another Lagrange multipliers. Here we take it as some another multipliers. Here we are using the given problem constant is L, M, N. So we take it as some another multipliers L, comma M, comma N. So we are using the subsidiary equations. So multiplies in that L second first fraction and then M second fraction, third one is N. So you get the each fraction is L dx plus M dy plus N dz divided by automatically denominator goes to 0. So we get L dx plus M dy plus N dz. So equal to 0. So automatically we get to integrate with respect to x. So Lx plus My plus Nz equal to C2. So we get the second solution. So we can write the general solution format is f of u comma b equivalent to 0. So here we get f of u comma v or otherwise f of c1 comma c2 equal to 0. So f of c1 means x square plus y square plus z square. C2 means lx plus my plus nz equivalent to 0. This is the general solutions of Lagrange linear multiplies method.